Welcome to Hitchin Hackspace's laser cutter training video. The full training session is split up into 5 sections, which cover the key parts of the system, safety hazards, capabilities of materials, and then a walkthrough of the full operation. That's followed by a hands-on session cutting a simple design. This video covers all of the theoretical parts of the training at a high level, and then any questions or project specifics can be covered as part of the hands-on session. The laser cutter is a Just Add Shark's Black Nose A3 laser cutter. The laser generator itself is a glass tube that's water cooled and is created by a very high voltage. The tube is covered by the casework at the back, and because of the dangers of the high voltage, please don't open the covers. The laser light then reflects off several mirrors before being focused by a lens to cut or mark the work. So don't touch the mirrors, as not only might they get scratched, grease residue from fingers can absorb energy from the laser and damage the mirror. The mirror and the lens are on a moving gantry controlled by step motors, shafts and belts. The laser and step motors are driven by a control panel, which we'll cover in more detail in a later video. To support the work, there's the bed, and there's 3 beds to choose from: the honeycomb bed, knife edge and the flat bed. Typically the honeycomb bed is preferred for small items, the knife edge for larger pieces from sheet stock, and the flat bed is used when you're working with an existing item such as a wooden box. That's all there is to the main laser cutter unit. It's supported by a number of peripherals, such as there's a small compressor in the loft, and that's used to blow air out of the nozzle to keep the lens clean and assist the cut. There's a chiller under the laser that uses a passive heat exchanger unit to keep the laser tubes cooling water cool. This display on the front of it shows the current temperature. If the temperature gets too high, it can reduce the life of the laser tube and an alarm will go off. This alarm is what you can hear when you first turn the laser on. Finally, there's the extraction system. Air is drawn through the front of the laser cutter, over or under the work, out the back, and then through the duct into the outside. Other related items are the PC used to program the laser and the nearby fire extinguisher. Now we've covered the components, it's time to talk about safety. There are at least 5 distinct hazards associated with using the machine. Can you name them all? Pause the video and see how many you can identify. The key hazards, as covered by the risk assessment, are fire and the harm that goes with it, such as heat and smoke, laser burns, either to the skin or eyes, entanglement or impact from the moving parts of the machine, electrical, both mains and the high voltage for the laser, and toxicity from residues or gases released as part of cutting. So, how did you do? Did you get them all? To cover those safety hazards in more detail, fire is actually quite a likely event with laser cutting, which is why we need to be extremely vigilant when using the machine. It's very important that the cutting process is continually monitored, with the user being in the machine at all times, so that if there is any fire, it can be dealt with appropriately and as quickly as possible. If there is a fire, the first response should be to pause the machine, as typically that's enough to stop the fire. It's not self-sustaining normally. It's really important not to panic and evacuate the building, as then it's basically guaranteed that the fire is going to get worse and overcome the machine and the building. If it's still relatively small but doesn't quickly die down when you pause the laser, press the arrow keys to move the head out of the way. This is partly for access, partly to avoid damage to the lens. And then either blow on the fire or smother it with whichever is to hand, such as a scrap piece of material. If you're not comfortable with that, or the fire has got larger, then absolutely use the fire extinguisher that's by the machine. It should only take a quick squirt to get it to be put out. There should always be a fire extinguisher by the side of the machine, and as a secondary place there's one near the front door. Ask for help if you need it at this point, but if the fire can't be brought under control with the fire extinguisher, then raise the alarm, evacuate and call emergency services, the usual things you would do if there was a fire in the building. While some fire is expected with laser cutting, radiation burns from the laser shouldn't be possible due to the door interlock, the fact that the laser can't fire with the lid open. So don't modify or defeat the interlock or disassemble the enclosure in any way. If you see anything unusual about the interlock or the enclosure, don't use the machine. Entanglement is a less severe hazard, but it's still quite likely and undesirable. If you have long hair that's not tied back, dangling clothing or jewellery, you need to make sure they're kind of tucked in or kept clear of the moving parts of the machine and keep out of the way of the head while you're moving it around manually. Hit the E-stop if someone gets tangled in it. From an electrical safety point of view, laser runs from mains electric, usual mains electric hazard supply. The laser driver itself raises that to tens of thousands of volts. That's well isolated, double insulated from the enclosure. So provided you don't open anything up, it's safe. As with any other mains electric item, if any of the visible wiring is damaged, alert a maintainer and don't use the machine. Finally, toxicity is a tricky one, as it's not visible and it can be cumulative. So if unsuitable materials are used in the laser cutter, they can release harmful gases or vapours. Whilst they will be mostly removed by the extraction, they can also accumulate and condense within the machine, leaving toxic residues. So a critical control for this hazard is absolutely limiting the materials that can be used in the laser. Only use materials when you're certain they're safe for laser cutting and you're certain of where they've come from. Refer to the wiki for a complete list of allowed materials. Beware that online you'll find other websites that list materials that are possible to laser cut, but they often don't consider the safety implications or the extraction requirements to cut them, especially on a machine like ours. In particular, materials such as PTFE, PVC, black acetal, ABS, treated leather, or fibre reinforced materials such as FR4 or carbon fibre, they're all known to produce toxic compounds when they're cut, so don't use them. So having covered what mustn't be cut, what can be cut? Well, most wood can be cut, but if it's something with an adhesive in it, such as OSB, plywood, hardboard or MDF, it needs to be the laser safe version. There's suppliers that will sell these materials with a laserable adhesive within them. It doesn't release formaldehyde, for example. Laser safe ply can be cut up to 6mm thick, and engraving works quite well on most woods, so you use a lower power and you can kind of mark the surface or cut partially through, either on a continuous path or rastering an area. There's acrylic, that cuts great, leaves a really nice finish. Up to 10mm thick is possible, but very slowly or with multiple passes. 6mm works really well. Acrylic also engraves well, but it doesn't leave much of a contrast in some materials. So you get kind of a groove, but it might be the same colour as the base material. You can get special sign making material that's laminate of different colours, and then engraving just removes the top surface to leave much more contrast and very visible signs or labels. White Delarin is really good. I really like it as a kind of structural material because it's probably the strongest or toughest laserable material, although it's a little bit more expensive than the others we've talked about. Most other plastics melt rather than cut, so you get a horrible kind of furry edge or melted edge, like polypropylene or polycarbonate. They're kind of a bit borderline unsafe. Some plastic foams can be cut okay. See the wiki for more information. Paper and card can be cut very quickly. They can be used for like crafting, but they're also great as a prototyping material. So whether you're going to be making something from wood or plastic or even metal, it's good to do a quick prototype and cut it out of card and check you're happy with the design. That's it for materials that can be cut all the way through. There's a few that can be just engraved though, and they can be used for quite nice items. So glass and slate can be engraved, they leave quite a nice mark, as well as some coated metals such as certain anodized aluminiums. You can get specialist coatings to apply to metals that will leave a mark when engraved, but they're quite expensive. That's it for the theory. The next video will cover the full operation of the laser cutter. See you there.